Hi, my name's Matt Basile, and I'm a program manager with the Azure Data Lake team. And today I'll be walking through how to build a simple end-to-end data pipeline that copies data from an existing cloud source, moves it onto Azure Data Lake Store, and then connects it with Power BI so you can start building business analytics off of your data. This is a simple pipeline and definitely does not showcase the full extent or power of any of the Azure tools here. It's mainly to help new users such as myself to get started, and then later you can go back to this pipeline and build onto it to explore more of the functionality that we have to offer. Our first step in this pipeline is to copy our data from our existing cloud source, in this case Amazon's S3, to our Azure Data Lake Store, and for this we'll be using Azure Data Factory. Before we can get started with Azure Data Factory, first we'll need to make sure that we have the correct permissions from our S3 and ADLS accounts. First, on AWS, we'll go to our IAM account and create a new user to assign permissions to. Programmatic access, because Azure Data Factory needs an access key and secret access key to access your S3 account. And here I've already created an end-to-end pipelines group that allows me to copy data out of my AWS bucket. So I'll just add my user to this bucket and create the user. And then here you can see I'll have an access key ID and a secret access key, which you want to save for later so you can add it into your Azure Data Factory. To assign permissions to our Azure Data Lake Store account, we'll first create a web app through Azure Active Directory. This ensures that no matter what region or when we're running this pipeline, it will always have access to our Azure Data Lake Store account. In the Azure Active Directory blade, go to App Registrations, and then New Application Registration. Here, you enter your name of the application, for example, end-to-end sample, keep the type as web app or API, and then use any URL of your choice. Once the application has been created, search for it, and here you can already see your object ID. You can copy that and save that for later. In order to get a secret access key, click on the keys blade on the right side. And then here you can create a new key. So I can create one for AWS to ADLS copy, set my duration. And then once I save it, you'll be able to access your secret access key on the right. And you'll also want to save that for later as well. Now that we've gotten secret access keys for both our AWS and our ADLS accounts, we can start building our pipeline through Data Factory. So navigate to your Data Factory, which I've already created, and click on Author and Monitor to get to the new UX, which will make building the Data Factory much simpler. So here we can click on the Copy Data Wizard and we'll get a step-by-step walkthrough to build this Azure Data Factory. Now, any data factory is composed of 5 parts. You have an integration runtime, you have a linked service for both of your source and your sink, and you have a data set for both your source and your sink. Now, this may seem like a lot of parts just for a simple copy activity, but each of these objects can also be reused in future pipelines. Once I established a linked service between my AWS account, I can use that for any pipeline with more functionality added on later, and the same for my AWS account. Now that we're at the copy wizard, we can see that it will lead us through step-by-step defining our pipeline, our source, our destinations, and additional settings as well. So we'll give it a name, AWS to ADLS, a quick description, and we only need this to run once. So now it's time to define our linked services. So my source data source is Amazon S3. We can keep the default name, and we can also create our integration runtime here. You can use the default Azure integration runtime. but creating your own and defining a region for it will ensure that no matter the region of your AWS or your ADLS account, the data will always run successfully. But this is an optional step. And now I can copy in my access key ID and my secret access key from the previous step. Now that we've copied in our access key and our secret access key, we can connect to our AWS account. And we'll know that we were successful because you'll be able to see the data inside your bucket right from this screen. And now it's time for us to select the exact data we want to move. So I can navigate through my AWS bucket right through ADF. Now, the data that I'm using for this example is the air quality index data that I got directly from the EPA's website. You can find it yourself through a simple Google search. This data contains information about the number of good, bad, moderate days based on air quality, summarized by county throughout the entire country for the past 20 years. So now that I've selected the folder including my data, I have a few options here. Since this is a simple pipeline, I'm not going to add any additional functionality to this data set. I simply just want to copy the files over. But as you can see, you could copy the files recursively if you had a nested folder structure, which I do. And you can actually also decompress folders directly through Azure Data Factory. What you can also see here is Data Factory also has the option to format your files while it moves them. For example, I could change my folders from comma delimited to tab separated, or even to JSON or other formats of your choice. And to confirm that I'm using the correct data, you can even view a preview of your data down here at the bottom. One thing to note is that this data does contain column names in the first row, so I'll be sure to check that box here. And then I can confirm that my data still loads correctly down here at the bottom. So now that we've created our linked service and data set for AWS, it's now time to connect to our data lake store. So you can see here, I have the option for a name. I can choose where I'm getting my data lake store from. I can select it right from my subscription and then choose my name directly from the dropdown. And for authentication type, we'll be using service principal, which means we are authenticating through the web app we created previously. So here I'll copy paste in the secret access key and access key ID that I got in the previous step. And once those are copied in, we can create our linked service and confirm that it connects properly. Here we can also see that we can choose an output file or folder. Azure Data Factory will create any folders that don't exist for you already, and also automatically try and create some based on your schema. But here I'll be choosing a pre-created location to move my data into. Here, you can also see that you can actually compress your data as you move it in as well, and also choose different copy behaviors, such as merging your files into a single one, or in this case, I'll be preserving the hierarchy that my folders are moving in. And then once again, you can choose the schema that you want your data to come in as, CSV, TSV, anything of your choice, even custom delimiters. But in this case, simple pipeline, I'll be just moving the data as is. Now we can choose fault tolerance settings for a pipeline. This is just to see how your pipeline handles errors. For example, you could log any rows that don't move properly. In this case, I'll just be failing out of my pipeline in case any rows fails. And finally, here we can summarize our entire pipeline, both of our linked services, our data sets, where we're moving our data from and to, and then finally, any policies we are implementing on our pipeline, such as retries and timeouts. And with that, we just have to wait for our pipeline to deploy and complete. And now we can monitor our pipeline. When using service principal authentication to get access to your ADLS account, you have to use a custom integration runtime. So I'm going to go back to our Azure Data Lake Store linked service and make sure I'm using a custom integration runtime as opposed to the default. And I can also test that connection right here to make sure I can access my data. Connection was successful, so we'll save. Now that we've edited our linked service, we can click on our pipeline over here on the left, go to the top, and click Trigger Now to run our pipeline. You can also do a test run where ADF goes through all of the steps of running the pipeline but doesn't actually move any data, which is a great way to make sure your pipeline works without going through the costs associated with it. Then we can click on Monitor here to track our pipeline's progress. And now we can go to the Monitor tab to view our pipeline runs. And you can see here that our most recent pipeline ran successfully. I can also navigate to my associated Data Lake Store account and go to the Data Explorer to view my data to make sure it made it over to the store successfully. And we can see here, all of my folder files made it into my Data Lake Store successfully. So now that we've moved the data into our Data Lake Store account, we need to perform some simple transformations on it to make it easier to work with in Power BI. And we'll do this using Azure Data Lake Analytics, or ADLA. So here I have the USQL script open in Azure Data Lake Analytics that we'll be using. And you can find this on the GitHub referenced at the end of the video. Now, this is a really simple script. All it does is extract the data from each of the individual AQI files and then combine them into a single file. Now, obviously, there's a lot more you can do with USQL. I can perform transformations on the data, combine columns, or even filter by certain columns, such as only looking at the counties that had an abnormally high amount of unhealthy air quality days. But here, for the basic example, we'll just be combining a set of files into a single file so that it's easier to work with when we connect to Power BI. Now, the way we go through an entire set of files in USQL is through this one line here. As you can see here, I have the path to our data and the general file name that all of these files have. But at the end here, I have two brackets, and in the bracket is what we call a wildcard character. And this wildcard means that we will extract data from any file that has that format, and then anything can be inside those brackets. So in this case, I'm labeling this wildcard as year, because that's the difference between these files, is they each have a different year in them. And then I can actually store this wildcard character as a new column that I'm extracting data from. So this allows you to actually extract data from the paths and file names of your files themselves, while simultaneously extracting from a group of files, which can be really powerful. And then here, I just output that extracted data, and I actually do order it by year, so another simple transformation using our CSV outputter, but you could output to another format of your choice, like TSV or even Parquet. And the final decision that we have to make before submitting this job is this AU slider here at the top. Now, AU is a measure of compute in Azure Data Lake Analytics. The more AUs you have, the more parallelized your job will run, assuming your job can be parallelized up to that much. But also, the more AUs you use, the more your job costs, as you can see by that estimated cost number on the side. Since this is a very small job, we're only operating over about 15 files, we'll run with 5 AUs and then submit. So now we're at the job monitoring page for ADLA, and you can see here a lot of information about your job. For example, how long it spends in each of the 4 stages, preparing, queuing, running, and finalizing. It's important to note that you actually only get charged for the amount of time your job spends in the running phase. So even if your job takes a long time to prepare or sits in the queue for a while, you don't actually get charged for that. And that also means you don't get charged for small syntax errors, since those get caught normally in the preparing phase of the job. Then you can see more information about your job, like the number of AUs, the estimated cost. And then once your job is in the running phase, you can see the job graph start to build. And this is a very simple job, so it'll probably have a very simple job graph. But for more complicated jobs, The job graph can be really invaluable in terms of breaking down where your job is and how your job's running and where potential blockers to performance may be. And once this job graph is done, we can actually see we have a vertex for each one of the files we're extracting from, and then a single vertex to combine them. So like I said, simple job graph, but you can already see how this could be really powerful when you're extracting from tons of files and going through multiple complex joins and aggregates. But for here, we can see that the job ran successfully. We can actually go back to our Data Explorer to check out that our cooked data now exists. And here we can see, if we go to our AQI, we can see we have an all states, all years file that we just created, which is the combination of all of our other files. And so now that we've cooked our data into a single, more readable file, it's time to connect it to Power BI and start getting insights out of that data. So now that we've loaded our data into ADLS and transformed it using ADLA, it's finally time to connect our data to Power BI and start getting insights off of it. So here I've opened up Power BI Desktop, and to connect to our Azure Data Lake Store account, we just go right to Get Data. Here under Azure, you can find Azure Data Lake Store, and now we'll need the connection string for the file where our data sits. And to get that, you can go back to your Data Lake Store account. You can see here the file itself. Click on the file, it will open up the Data Explorer, and then under Properties, you'll find the connection string. Once that loads, you can copy the path to your data, go back to Power BI, and paste that right in. Now, for larger files or larger sets of data, you can't directly connect ADLS to Power BI. You may need to go through SQL Data Warehouse or move your data into a SQL database first. But since this is a smaller data set, we can connect it directly to our ADLS account. Now here, you'll notice that although we've connected our file to Power BI, these aren't actually the column headers we want. This is metadata about the file, the date we accessed it, the date it was modified. So first we need to make sure that Power BI is actually reading the contents of the file itself, not just the metadata. So we click on Edit Query, and then all we need to do is click on this Combine Files button here under the Content table. So now, while it may not make sense for a single file, Combine Files basically means Power BI is going to read the file, and if there are multiple files with similar schema, it can automatically combine them into a single set of data. So now we just have to wait for Power BI to connect and read the contents of the file. And here we can see that Power BI is correctly reading and recognizing all of the schema in our file. So we can hit OK. And then once it loads that in, we can just hit Close and Apply up here in the corner to load this newly edited query into Power BI. So now you can see that all of our fields from our file are located here on the right. And so now we can start building some simple visualizations. For example, we can take a graph that has each year and then compares the number of days with a high carbon monoxide value based on the county. So we can see here, obviously this is a little complicated, but we could also go and drill down to look at a specific county, for example. And so now we can compare just these 4 counties and see the county of Ada has a pretty high carbon monoxide values. So another example we could do is to build a visualization of the country based on county or based on state. So we just click on our ArcGIS maps here. We load in our state as the location, and then we can load in the number of good air quality days that that state has as our color. And then this will take a little bit of time to build, but then you'll have a map of the country where states are colored in by how good their air quality was over a year. So here you can see darker states had worse air quality while lighter states had better air quality. And these are just a few examples of the types of visualizations you can build with Power BI. Obviously, two very simple examples, but there's really a lot you can do by mixing and matching these different fields and then also creating your own fields. And then, for example, sorting based on different values, high levels of CO2, things such as that. And so there you have it. That's how you build a simple end-to-end pipeline to move data from an existing cloud source into your Azure Data Lake store, transform that data using Azure Data Lake Analytics, and then finally connect Power BI and start getting insights and analytics off of your data. If you want more information about using Azure Data Lake, you can find documentation at that first link. If you want access to the scripts and more information about this pipeline, you can go to the GitHub located there. And then finally, if you have questions about recreating this pipeline or how you can expand upon it to meet your own data needs, feel free to reach out to me at mabasile@microsoft.com. Personally, I found this to be a really rewarding experience to learn how to get started with Azure and the different services it offers. And also, I now have a simple pipeline that I can go back to and add on functionality to try out new features. So while the startup cost may have been a little bit high, now to get access to all of the functionality of Data Factory, Data Lake, and Power BI, it's now much easier to do that. And so I'm personally excited to try out new features and to continue exploring Azure. And I hope you are too. I hope you recreate this pipeline and try it for yourself. And once again, please feel free to reach out if you have questions or comments about this. So this is once again Matt Basile from the Azure Data Lake team, and have a great day.